Hey everyone, and welcome to today's Explainer. We are embarking on a really fascinating journey into the world of chemistry. Now, we aren't just going to be talking about mixing random things in a lab today. Chemistry is actually the fundamental language of perfect, universal order. And chemical equations? Well, those are the sentences that make up that language.
To set the stage, 1 Corinthians 14:40 says, "But everything should be done in a fitting and orderly way." It's kind of wild how perfectly this ancient wisdom applies to modern science. Because just as order brings clarity to our daily lives, it brings ultimate truth to the laws of science. So today, we're going to learn exactly how to find that perfect order right down at the microscopic level.
Here is our quick roadmap for today. We'll cover the need for chemical order, the law of conservation of mass, coefficients versus subscripts, how to balance equations, a check of your understanding, and finally, education, morality, and peace.
All right, let's jump into Section 1, the need for chemical order. Like I mentioned, chemical equations are the actual sentences of the chemistry language. If an equation is unbalanced, it's basically a chaotic, broken sentence. It just doesn't reflect reality.
So, how do we actually bring that order? Well, here is what you are going to learn today. How to accurately count atoms within formulas, how to balance equations by adjusting coefficients, and exactly why balancing perfectly proves the absolutely incredible law of conservation of mass.
Moving right along to Section 2, the law of conservation of mass. Honestly, this is the big why behind our entire lesson today. The universe has this strict, totally unbending rule that mass must always be conserved.
The law of conservation of mass dictates that atoms are simply rearranged in a chemical reaction. Equations must have the exact same number of each type of atom on both sides of the reaction. Atoms don't just magically disappear or poof into existence out of nowhere. They just form new bonds. So both sides of our equation have to perfectly match. Okay, Section 3. Coefficients versus subscripts. To balance these chemical sentences, we have some specific tools we can use, and some very strict rules we absolutely cannot break.
The crucial difference is this: subscripts are the tiny numbers written down low, like the 2 in H2O. They tell you the true identity of the compound. You never, ever change these. If you do, you're literally changing the substance entirely. Coefficients, on the other hand, are the big numbers placed directly in front of the formulas. Think of these as your primary tools to adjust amounts and achieve perfect balance. You can change the big numbers, but seriously, never touch the tiny ones.
Now for the really fun part. Section 4, how to balance equations. We're transitioning from the rules to the actual application here. Get ready to look at real chemical reactions and see this ordering process in action. It's like a giant puzzle.
Take a very simple equation. H2 plus O2 yields H2O. Let's count it out. We've got 2 hydrogens and 2 oxygens on the left side, but wait, only 1 oxygen on the right. We supposedly lost an oxygen atom, and the universe says, no way, absolutely not. To fix this, we use our coefficients. By placing a large 2 in front of the H2, we get 4 hydrogens. We leave the O2 alone. Then we place a large 2 in front of the H2O on the right side. That gives us exactly 4 hydrogen atoms and 2 oxygen atoms on both sides. Mathematically perfect.
Let's level up a bit to a combustion reaction. CH4 plus 2O2 yields CO2 plus 2H2O. By systematically adding a coefficient of 2 in front of the oxygen on the left and a 2 in front of the water on the right, we achieve total balance. Verify it with me real quick. 1 carbon on both sides, 4 hydrogens on the left, and 2 times 2 is 4 on the right. What about oxygen? We have 4 on the left, perfectly matching the 2 in the carbon dioxide plus the 2 in the water on the right. 1 carbon, 4 hydrogen, 4 oxygen. Perfect harmony.
Finally, let's look at a synthesis reaction. Notice how elegantly the atoms mirror each other here. To balance the 2 chlorines on the left, we place a coefficient of 2 in front of the NaCl product on the right. But oops, that gives us 2 sodiums on the right, which is exactly why we needed that 2 in front of the Na on the left to begin with. The final count is 2 sodium and 2 chlorine atoms perfectly matched.
All right, that brings us to Section 5, check your understanding. Now it is time to shift gears from my demonstration to your action. It's your turn to practice bringing some order to chemical chaos.
Here is your homework assignment. First, reflect on why equations must be balanced in the first place and what coefficients actually do.
Then tackle the math. Try balancing the nitrogen and hydrogen synthesis equation and the iron oxidation equation. Finally, remind yourself why those subscripts are totally off limits. Apply your new tools and always remember the law of conservation of mass.
Finally, let's step into Section 6, Education, Morality, and Peace. I want to zoom out for just a second. From the micro skill of balancing microscopic atoms to the macro philosophy of balancing our lives and our choices.
Romans 8, verses 6 through 7, promises peace of mind to everyone who keeps their mind spiritual. Think about what we literally just learned in chemistry today. Out of balance, things represent chaos, right? But with rules and structure, we find perfect order. Well, true peace of mind works the exact same way. It's the direct result of keeping our thoughts grounded in spiritual order.
This is the core philosophy behind the heroesmartacademy Godly Learners series. The source material firmly believes in intertwining biblical morality with education. And why is that? Because education without morality will ultimately hurt. Really, what is the point of being smart or knowing how to perfectly balance chemical equations if we continue making bad life choices that hurt ourselves and others? True, meaningful education must always be paired with a strong moral compass.
I want to leave you with this final, pretty powerful thought. If the universe demands absolute, unbending order in its chemistry, literally down to the very last atom, how will you bring order to your choices today? It's a question I really hope empowers you to apply both the scientific rigor you've learned here and the moral order we've discussed into your everyday life. Thank you so much for joining me on this explainer. Keep learning, keep balancing, and stay curious.